For this next experiment, I have a microcontroller board generating serial data on this one line, and that is connected to an analog pin as well as a digital bus pin on the Rohde & Schwarz RTB 2004. Whenever I switch this on, it's going to start transmitting data, and then it's going to pause, and then it's going to reset itself, and so on and so forth. So it loops through that routine. So let's see how we can capture that data and decode that data on the scope itself. All right, so the first thing that we need to do here is go into the protocol menu and select that we're going to be decoding a UART. So to do that, all I need to do is change the bus type from whatever it is to UART, enable decoding, and then go into configuration. Here you can see I have options for the source. If I click on the source button, you can select between analog channels and the digital channels. I prefer the analog channel for now. I've set the bitrate predefined. You can have an user-defined bitrate as well, but I'm going to just go ahead and do that. It's going into the trigger menu. I'm going to change it to normal. I'm going to show you why, but I'm going to trigger from source B1. That's bus 1, and it's a serial type trigger. Go back on that. Now I'm going to turn on my DUT. There you can see that this is my bus decode, and there's my channel. So I'm just going to switch on the unit, and it's going to start chunking out data. So you can see there's a lot of data flowing out, and then there's some other stuff going on. I'm going to just scale it vertically. Hold on a second. Let's scale channel 1 vertically. One of the things here is amiss here is the absence of individual vertical scale knobs and stuff, so that would have been beneficial. And I'm going to scale this horizontally as well. Move this a little towards here, and there we go. And now, channel 1, there we go. Okay, so now I'm receiving some data. Let me shrink it down a bit. It's decoding it. It's basically counting from 0 all the way up to 127. All the way to 15, and then it adds a glitch of 127D, and it stops for about 5 seconds, and it continues again. Now, the first thing I wanted to do was to be able to capture the history, so using the history segment. So what I'm going to do is I don't need to do any kind of extra configuration. All I need to do is select the memory depth. Now when I click on the record length, I can see I have 771 history segments, which means it will capture memory segments of 200 kilosamples per trigger. All right, so if I just stop right now, just click on stop, go into history, and just click here, I get a very long segment table. So it shows me all of the data that it's actually captured since I started the capture process. If I click on run, it'll just cycle through that data. Right, if I click on the speed here, click on run, it'll cycle through all the data without a pause, even though there was a 5-second pause. So it's basically recording all the data. I'm just going to switch off the DUT at this point. So my microcontroller is switched off at this point of time, and it's looping through the data that it already had recorded. So this allows me to kind of scroll through the segments, or through the data that I had received on the bus line. So I can go into previous, tap through the events one by one, so on and so forth. So I can just scroll through all of these packets one at a time, and I can export this table, I think, as well. And I can go click a number, -12, and enter. So it's the history. So 0 is the current time, and this one is the 12th sample from the current. So that's one way of looking at the data that was captured. Using a single shot memory trigger, that would have been impossible. The second thing that we want to do is to be able to capture data from a particular event. For example, if I want to, I'm just going to turn off history. What I want to do is, at this point, the microcontroller is switched off, so I'm just going to go and run the process. Sorry. You can see there's no data because the controller is switched off, but I want to be able to capture data once I start, and I want to inquire about, say, 20 samples. So I go into the acquire menu, and here all I need to do is change the NX single to, I'm going to do 20 samples now, right? Enter. So it's going to capture 20. Instead of run mode, I'm going to click on single. No triggers yet. I'm going to start up the controller again, powered on. There we go. And it's not completed 20 samples. And there we go. So now it's stopped, even though there were more samples coming in, it stopped at 20. Taking a look at the history now, I can see the 20 samples in my trigger. So starting from 0, that's the current sample, all the way to the first sample that was captured. So I can go into minimum 19. And that's my first sample. Now I can scale down, I can do an analysis on this, I can zoom in, zoom out, so on and so forth, all right? Segment table. Now if I want to go into, just scroll through these, and you can see data 255, that was a glitch, and 0, 1, 2, 3, 4. So that way I can capture a dump of the samples as they happen, and I can now do an analysis about where something went wrong and where is my first glitch happening. So I'm just going to go to next sample, next sample, next sample, next sample. Oh, there we go. So after 15, instead of going to 16, it kind of dumps 127 in decimal on it, and that's the code actually. So that's the kind of debugging and diagnostics you can do with the history mode, and that's where most of this stuff kind of comes into use. Of course, you can do the same thing. You don't need the analog channel. You can do the same thing with the digital logic channel. So just going into the protocol menu, conveniently there's a single button for the protocol menu. Going into configuration, you can change this to D0. Go back again, single trigger, and you can see now it's triggering from the digital channel, and yeah, D0 is connected to from the logic analyzer is connected to my microcontroller board. So that kind of stuff is really useful, and that's basically how the history mode or the segmented memory mode of this thing kind of works. Even though the add-on, the history mode, of course, is options. So even though there is the K15 history and segment memory, so this is an option, and I think it's pretty expensive actually, but it's pretty useful if you're doing a lot of bus decoding and all of that kind of stuff, and you want, or even if you're doing some kind of thing with analog triggers and something. So that kind of stuff becomes really, really useful.